Hello, you're welcome to my YouTube channel. Thank you for stopping by. Today we are learning how to simplify algebraic expressions. Before we dive right in, let's talk about algebraic expressions. What are they? Algebraic expressions are actually statements represented mathematically using letters and numbers. So instead of just saying the words, we bring them down mathematically by expressing them in terms of a mixture of numbers, letters. Okay, so for example, if I had 3 packs of biscuits and with 2 extra pieces, to express this mathematically, I would say 3b plus 2. 3b being the 3 full packs of the biscuit and the plus 2 representing the additional 2 extra pieces. Now, if you observe that this particular statement that I have said and I have written down algebraically right here as 3b plus 2, it consists of 2 parts. These parts are referred to as the terms in an algebraic expression. So our algebraic expression 3b plus 2 consists of 2 terms separated by the operator plus. Okay, now the first term is 3b, whereas the second term is 2. But there's a bit of difference between these 2 terms. The first one, as you can see, consists of both a number and a letter. That letter we sometimes refer to it as a variable. Now, the number in front of the variable is called the coefficient of that variable. It tells you how many times of that variable you have in that particular expression. In our case, we have 3 packs of biscuits. That's why we have it as 3b. The other number, that is the other term here, is our constant. It doesn't have any variable attached to it, so refer to it as a constant. Now let's get into the real business of the day. To simplify an algebraic expression, we need to collect like terms. You may begin to ask, what are like terms? Like terms are terms that look exactly alike. Tautology? Nah. What I really mean is, for 2 terms to be called like terms, it means they have exactly the same variable in the same power. So if the variable is, say, b, a like term will be any other term in an expression that has just the variable b. If it is a combination of variables, say x, y, a like term will be another term in the same expression that has the same combination of x and y. Not to worry, we're taking a few examples now. Now, our very first example here is we're told to simplify 2y plus 3y. Now, since the terms are exactly the same thing, all we need to do is to obey the operator between them. 2y plus 3y is going to give us 5y. Easy peasy. All right? Now, to the next question. We're told 9x minus 10x. The operator in between them is the negative sign. It means we need to subtract from 9x, 10x. When we say 9x minus 10x, is going to give us minus 1x. But when we are writing in algebra, we don't put minus 1. So really, the final answer here should just be minus x. All right. Now, the next question here, question number 3, has a combination of variables. We can say we have 7c minus 5d plus c plus 3d. To do this properly, we need to collect the like terms. What are our like terms here? Our like terms are terms that both have c or they both have d. So the very first term I have here is 7c. I write that down. The next term that looks like it, that is, that has the same variable as it, is just c. And it has a plus sign. So I say 7c plus c. I've addressed all the terms that have the variable c. So I move on to the terms that have the variable d. The very first one is minus 5d. And then finally, I have plus 3d. Now I have collected the like terms. I have put them together. I can now go further and simplify this. 7c plus c will give us 8c. Minus 5d plus 3d is going to give us minus 2d. So simplifying the expression, 7c minus 5d plus c plus 3d is going to give us 8c minus 2d. Please note that whenever you are trying to collect like terms, you are rearranging the expression. In the B to rearrange the expression, ensure you move each term with the operator in front of it. Notice when I moved the C, I moved it with a positive sign in front of it. And also when I wrote down my 5D, I wrote it with the negative sign right in front of it. Each term has a sign in front of it. Look out for it and make sure you don't misplace them. All right, let's hurry on to question number 4 here. For question number 4, we can see that we have a couple of different scenarios. We have 4xyz, we have minus 3xy, we also have plus 2xz and minus yxz. If you look critically at this particular expression, we have just two terms that are like terms. Here, the 4xyz and the yxz. Oh, am I sure about that? Yes, because this yxz could easily have been written as what? This is the same thing as xyz. The letters were just moved around. Don't be confused if you see a situation like that. All right, so let's collect our like terms. We have 4xyz minus xyz minus 3xy plus 2xz. Now that we have collected our like terms, we'll observe that we have 4xyz minus xyz. That's just going to give us 3xyz. And then we have minus xyz. Sorry, that's an error. I've dealt with that. We have 3xyz minus 3xy plus 2xz, and that's our final answer. We cannot simplify this expression anymore because there are no other like terms. So we're done collecting like terms and we have simplified the expression. Finally, let's take a look at question number 5. We have 8x minus 4 minus 2x minus 3x squared. Now, the like terms here will be the 8x and minus 2x. So we collect them together to start with. We have 8x minus 2x. And then we move on to the next term we've not addressed here. That is a minus 4 and then minus 3x squared. 8x minus 2x is going to give us 6x minus 4 minus 3x squared. Can we do any more with this? No, we are done. We have collected the like terms. We cannot solve this because it is not an equation, but we have successfully simplified this by collecting our 8x and minus 2x. I hope you understand what we have done today. If you have any questions, please leave them in the comment section. Thank you for stopping by once again. But wait, have you subscribed? Please do. See you in the next one. In the next video, we'll be talking about how to expand brackets. See you soon.